A solid revolution is a solid figure obtained by rotating a plane around a straight line that lies in the same plane. For example, imagine a revolving door. This is created by a rectangular piece of glass that rotates around a vertical line. So if you're thinking about a revolving door, there's a fixed line right here, and it's a rectangular piece of glass that's just rotating around that fixed line to create a cylinder. That's what we're talking about here, rotating a 2D figure around a straight line to create a 3D figure. So 92 through 94 say to properly name the solid that is formed by rotating each of these figures about the line given, and sketch it. And we're going to use the proper geometric names. So if I were to rotate this around line M, it would rotate like this all the way, and sorry, this should be actually more pronounced up here, all the way back to its starting point. And then if I rotated this point here, that would rotate like this back to its starting point. And if I rotated this point here, that would rotate like this back to its starting point. And we can connect some lines together. So these 2 points are connected, and so these 2 points are connected. So we do see a cylinder shape. And then we have something like this. Okay. So we really have something that looks like this. And then there's a cylinder running through it, and that creates actually a hole. The yellow figure is part of a cone. However, it's not called a part of a cone. There's actually a geometric name to it. It is a frustum. And then there is a cylindrical hole running through that frustum. So that is, we have this figure sketched here and also off the grid, and we named it using the proper geometric name. That's it. Okay, so the next one, number 93, I'm going to rotate around line L. So this point's on line L, so it's going to stay where it's at. This point's going to rotate around like this, and this point's going to rotate around like this. So we have something that looks like this. Or off the grid, we have a cone connected to a cylinder at its base. Looks like this. So that's exactly how we're going to name it. A cone connected to a cylinder at its base. All right, and then the next one, this point's going to stay where it's at, and this point's going to stay where it's at because it's on line M. So then we're going to just rotate this point around and then connect my points together. So I have a cone and another cone. Both cones are connected at their bases. All right, So now we're going to draw what the following solids would look like on the 2D plane before being revolved, and then we're going to name them. So for number 95, I have a line on my 2D plane, and this is actually, it looks like a donut or an inner tube. It's actually called a torus. That is the proper geometric name for this shape. And a torus is created when we have just a 2D circle rotated around the line, like so. Okay, now number 96 is called a hemisphere. And this is created when we have something that looks like this, a fourth of a circle connected to our line. Now the circle on number 95 is away from my line because we have a hole in the center, and to create that hole, we need our 2D shape not attached to our line that we're rotating it about. The hemisphere does not have any holes, so that's why it's connected to my line that I'm rotating it about. Number 97 is that weird looking part of a cone, and again, that's called a frustum. A frustum is created by, and this frustum does not have a hole in the center like this one did up here. A frustum without a hole is created like this. And then we rotate at every point around the line this way. And then lastly, this is a cylinder with a cylindrical hole. So how the hole is created is with our 2D shape not being connected to the line that we're rotating it about. And how a cylinder is created is it's created by a rectangle being rotated about our line. All right, that brings us to the end of this lesson.